So we're here on a tremendous Thursday, or it could be thunderous. Depends on if you had beans last night. Don't forget, hit like, hit subscribe, hit the bell. Today we're looking at multiplying polynomials. Okay, so I'm actually going to show you two methods, and you get to take your pick. So we know from distributive property that it's 3 times x, and then 3 times 2, which is 6. Okay, that's what we should have right here. But in the event that you have, now, this is a binomial, this is a binomial. Okay, well, polynomials, poly means meaning, numbers means term. So a monomial, like 3 is a monomial because it's one term. This x plus 3 is a binomial because it is 2 terms. And if it was 3 terms, trinomial, and then they got really tired and they said anything 4 and above is poly. Okay, so if we had a binomial times a binomial, we'd actually cut it right here with our ninja sword. Okay, and then this is what we did here. We put this first term here, and we put this second term here. Okay, so basically we're saying this first term distributed to everything in the second grouping. The second term distributed to everything in the second grouping. Okay, and all you would do here is multiply. So this is, x in the first, this becomes x squared. Pew. This becomes 2x. Pew. This becomes 3x. And this becomes 6. Now, after we multiply it, we would actually need to, combine our like terms. And usually our like terms are going to be these right here in the middle. Okay, because there's no other x squareds, there's no other constants. Okay, let's say you have two not Rice Krispies, two Reese cups, and you go to the next house and you get 3 Reese cups. How many Reese cups do you have? 5. What else do you have? Diabetes. Very good. I can say that because the doctor said I am pre-diabetic, so working on that. And I have a daughter that's type 1 diabetic. Yeah. But she's in college she's in med school to be a doctor that deals with type 1 diabetes. All right. So this is basically what we're doing today. It's called double distributive. Now, I'm going to show you a different method with the same problem. Okay. Some people like it, some people don't. Okay. That's close enough. Okay. So if you do the table method, it looks like this. You could take, I usually do the first term vertical, or the first term. So I would put x here plus 3 here. And then I would do x here plus 2 here. Now, some people like this because they can see it better. Okay. Some people don't because they're like, oh, it takes too much time to draw the box. Okay. Well, what you do Nope. I know what you're talking about, but no. Well, it could be like science. Okay, it could be. All right, so we would do the same thing. So we got x here. That's is x squared, 2x, 3x, and 6. So what you would get here is when you multiply x times x, you get x squared. Okay, x times 2, 2x. That way you have different options. You still get the same stuff. Yes. Oh, I was trying to. The question was, why did I put that as a bi and a bi? That's because this is a binomial because it has two terms. These are your options if you have a binomial times a binomial. You can do double distributive property or the table method. Okay. This was a mono times a bi, which we have done for years and done regular distributive property. Yep. hmm Yep. Now, um, also, um, if you ask your parents or somebody over the age of 35 that you're doing this, they're going to say something called FOIL, which is basically another way to do double distributive property. This is the way I was taught. This was the only way I knew existed up until like 2015, which is sad. Okay. All right. So, number one, which way do you want to do it? You want to do double distributive or a table? All right. So, let's cut this. So, we're going to have x times all this, and then plus 2 times all this. Okay. Well, this becomes x squared plus 5x plus 2x plus 10. All right. Again, when we do this, our middle terms are the only ones we're going to combine. So this becomes x squared plus 7x plus 10. Okay. It seems like a lot at first glance, but once you get in the habit of doing some of them, it goes a little bit better. The hardest part is knowing how to set it up. Once you know how to set it up, you are all about it. All right. So for number two, if we do number two at double distributive, we'd have x times all this in the back. And then this other term, this is a minus 4 this time. So we would say minus 4. All right. So once we do this, then this is why it's called double distributive, because we're about to do distributive property twice. All right. All right. So, you know, x times x squared, x times 7 is 7x. Negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. So we just combine these. Okay. Now, imagine if you're out trick-or-treating, you have 7 Reese cups, you eat 4 of them. What do you have? Exactly, 3 Reese cups. Have y'all figured out like what is my favorite candy yet? Okay. All right. Now, while we're waiting for people to catch up, hey, snacks. Why do vampires hate mosquitoes? That's right, too much competition. Yeah, we know I have history with mosquitoes. When I squished that one before it got on that baby and splattered all over its uniform, so it or its outfit, so it looked like a crime scene victim. All right, number 3. How is number 3 different than 1 and 2? Well, the on the first two, they do have two different. They do have, yeah, number 3. Well, we're supposed to be right here. Okay. So what this means is this is multiplied. This whole thing is multiplied by itself. All right. So when we do that, now we can set it up. Oops, wrong spot. Much better spot. Good Deadpool. Bad Deadpool. And then we combine our like terms. All right. That's number 3. Yes. Because remember from what we had the other day, are they the same variable with the same exponent? Like, basically, I kind of think about it this way like the x squared is the varsity, the x is the junior varsity, and this is the freshman team. They look like they could all be together, but they're really not on the same team. All right. So number 7 is slightly different because of different numbers. For those that's not paying attention in the in-class audience, it's great. It's awesome. All right. So it's really nothing different. It's the same process, just with different numbers. Okay. We had a testing day yesterday. That means that some of these kids didn't see each other. So it's not like they don't have technology to catch up with each other, but they wait for my class to do it. There's so much tea being spilled right now. It's like the Boston Tea Party, man. It is bad. I hadn't seen this much drama since they tried to, add more episodes of stuff on TLC. All right. Are we good with 7 and 8? All right. Now, couple ways we can do this one. I actually had a student last year that said, "Hey, Mr. Jeffries, watch this." They did this. They cut this, and I'm going to show you why. They started doing it like this, and I like it because just wait. Now, if we break up this one is actually called a trinomial. If we break this one up, hooray! May you broke up with your stinky boyfriend. May your nasal passages smell a lot better. I'm so glad my microphone can't pick up stuff. Now, this does seem odd, okay? But I'm going to show you why that they did it like this versus the other way. Now, the reason why they did it like this in green, now, if you do it like this, like on number 12, your like terms aren't going to be beside each other. Yeah, what circled is the answer to 11. What? Okay, if we have it like this, our like terms are not beside each other. Our squareds are separated. Our x to the first are separated. Again, you could do it either way. I just wanted to show you all this the easy way first. All right. So that was 11 and 12. All right. Shh. Let's do 15. Okay, we split it. Now, what we should notice when we start to collect like terms is our middle terms are actually going to cancel out. Negative 9x plus 9x just goes away, so I'm left with huh? Left with sleep? Okay. I don't know what's going on. I've never heard so many exhausted people talk so much. Shh. Golly. All right. Now, these two cases are actually called this. The they're the difference of two squares. This is I just need y'all to listen. So I need y'all to do something odd. This is listen. This is a squared term. This is a squared term. They are subtracted. That's why it's called dots. The difference of two squares. The dots is an acronym. Okay. Difference of two squares is normally how people say it. Okay. Now, as my Chatty Cathy class actually tries to work on their your turn for people that do remember that we are in class, don't forget hit like, hit subscribe, hit the bell. Farceness. Good stuff.